A good portion of our time on any software development project is going to be spent teaching our program to solve the types of problems it comes across on a regular basis. As programmers, we too will run into certain problems time and time again. Sometimes we're going to have to code our own solutions to these problems and hopefully save them for later use. However, more often than not, someone has run into these problems before. And if they've made their solution publicly available, one of our options is to leverage their solution for our own gain. In this video, we'll be using the math class library, which is bundled with the Java development kit, to solve some math problems for us. To start this video, create a brand new NetBeans project and enter the main function. We're going to write a very simple program. Let's declare a floating point number variable and give it a value. Don't forget the F at the end of our explicit number to let Java know that we've declared a floating point number. And then let's use system.out.println to print this value to the screen. Okay, there we go. Now, with this program, we'd like to make it really easy to raise our floating point number to various powers. So, if we simply wanted to square this number, I guess we could just print out the value of number times number. If we wanted to cube it, we could print out that value. And if we wanted to raise it to the power of 6, we could do something like this. Of course, this gets unwieldy pretty quick, and there's certainly a better way. Let's leverage the Java Math class library to help us raise numbers to varying exponential powers. Now, I've just told you that the functionality we're looking for lives in the Math class library. This is the kind of push in the right direction you should expect to get from a Google search, or if you're an experienced software developer implementing a specific API. Unfortunately, that's not quite enough information for us to start using the functionality of this class library. We don't know the specifics of how it works, or even exactly what functionality it offers us. To find this out, we're going to have to look at its documentation. Here's the documentation web page managed by Oracle for the libraries found in our Java development kit. Among these libraries is java.lang, which contains the math class that we've been looking for. Once we've navigated to the class library page, we get two things. First, we get some human-friendly text write-up about the library, its history, what its intended uses are, very meta-level stuff. If we scroll down, we then see the functionality and methods implemented by the library. This is the nitty-gritty and where we'd like to be. One of these functions should stick out for us. It's the POW, or power function, and it returns the value of the first argument raised to the power of the second argument. In short, it will allow us to raise numbers to an arbitrary power. Let's split up our screen here a little bit so that we don't have to flip back and forth too much, and get back to coding. All right, let's employ this power function to modify the value of our variable number on the line after we've declared it. We're going to do something along the lines of number equals pow, but we need to know a little more information. How exactly do we employ this power function? Well, if we click back to our documentation, we'll see that when the power function is declared, in addition to its name, there's also, between these two parentheses, two arguments specified. These arguments, double A and double B, are the two pieces of information the function is requesting before it can operate as expected. Our job, in order to use this function, is to replace the requests AA and B with actual variables or explicit values so that the power function can do its thing. Our documentation tells us that AA should be replaced with the variable or value that we'd like to raise to the power of a B. So let's replace the first type argument with our variable number, which is what we want to raise to an arbitrary power. You'll notice that I get rid of the double specifier when I do that. This specifier exists to let us know what type Java is expecting. On that note, number is a float, not a double, and that's going to give us some trouble, unless we simply change it. Now, we don't have a pre-created variable to replace B with, so let's just use an explicit value like 4. In theory, the power function now has all the information it needs to go ahead and run and raise the value of our number variable to the power of 4. However, NetBeans is still giving us our red warning sign. Right now, that's because NetBeans, and Java by extension, doesn't know where to find this keyword POW. For the same reasons that we need to specify a full path to system.out.println, we need to specify for Java the full path in which it can find the power function. That's the same path we followed to get to the power function in our documentation. So we're going to specify java.lang.math.pow. Now we're pretty much good to go. We need to erase this madness here and only utilize the number variable once in our println statement, and now we should be able to run our program. You can plug it into your calculator if you want, but I'm pretty confident that our program has just outputted the value of 4.321 raised to the power of 4. So this is great. We've just employed external code to not only make our program easier to write, but also to keep it very human readable. It required much fewer lines of code than it would have otherwise. One thing that's not superhuman readable about our program is these long paths to functions like POW and println. Is there a way we could shorten them? There certainly is. If the makers of Java had wanted to, they could have allowed us to call this function by simply typing math.pow in all instances. This, unfortunately, would have some unintended side effects. For example, if two libraries linked up to Java both declared a math.pow function, Java would not know which one to use. So by default, we're expected to link to libraries directly and explicitly. However, if we'd like to just be able to type out something like math.pow, we can import a library into the local space that we're working. We do an import command above our class and main function declaration, and all the import command takes as input is the path that we'd like Java to look for when it comes across a keyword like POW that it doesn't immediately recognize. In order to allow us to employ the easier syntax math.pow in our program, we simply need to import java.lang.math. There is some special syntax for imports. Let's say we wanted to import all of the class libraries in java.lang. We could replace .math with .star, which translates to .everything here. I should probably note that for those of us working in NetBeans, this import is done by default. But we're going to do it explicitly here because you may have to do it working in other Java environments.